Dear students, today I am going to discuss with your chapter number 7. That's a very important chapter, and the name of the chapter is your triangles. Okay, first of all, I want to introduce these some definitions, and after that we will discuss about the criteria how we can show the triangles are congruent. So first of all, we have to understand what is the meaning of the congruent figures. So such type of figures are called congruent whose size and shape both are same. Okay, so this topic of a triangle, so that's why I'm taking a triangle. See, this is suppose this is your first triangle and this is your second triangle. We say these two triangles are congruent because they have the same shape, because this is a triangle and this is a triangle. If we take a triangle and second is a rectangle, then we can't compare. Okay, so this is a triangle, this is a first triangle, and this will be your second triangle, and they have the same size. So that's why we say these two triangles are congruent. Okay, so such type of figures are called congruent if they have the same shape and same size. The second is that is called your CPCT rule. This is a very important rule. We usually use this rule when we solve these questions of your exercise. CPCT means corresponding parts of the congruent triangles. Okay, so what is the meaning of corresponding parts of the congruent triangles? Suppose this is your triangle number 1 and this is your triangle number 2. Okay, let us name these triangles. This is your A, B and C, and suppose this is your D, E and F. These are the two triangles. So corresponding part, this part and this part. Okay, I am taking here, see this part and this part. This is called your corresponding parts, and this part is equal to this part. This is equal to 3. This is a 3. So these are called your corresponding parts. Either these are the sides or you can take the angles. This is angle 1, this is angle 1. This is angle 2, then this is angle 2. Both are equal. See, I am taking here. This is your red one. This and this. So, okay. So such type of figures are called your these congruent figures, and these parts are called corresponding parts. This is this and this corresponding parts. This angle, this is called your congruent parts. Okay, of the corresponding parts of the congruent triangles. That's all. So this is first of all, this is an introduction, and now I'm going to discuss about the criteria of congruency of the triangles. How we can show the two triangles are congruent? Is there some rules? So these are the some 5 rules to show your triangles are congruent. Okay, we have to learn all these rules. Rule number 1 is that's your SAS, means side angle side. Okay, this is your side, then angle and side. Okay, so this is called your side angle side rule. Second is your angle side angle rule, and then the third is angle side. Fourth is side, and number 4 is your RHS rule, or sometimes it is called right angle hypotenuse side. Okay, so these are the 5 rules. By these 5 rules, we can show our triangles are congruent. Okay, now I'm going to introduce one by one what is the meaning of all these rules. Number 1, first of all, I'm going to take this. First is your sidewise side angle side. Okay, number 1 is, what is the meaning of this? So that means if we take side of one triangle, suppose this is your one triangle, and this is suppose your second triangle. Okay, he said that if side of the one triangle, that means this is a side of the one triangle is equal to side of the another triangle, and then angle of this one, this is the angle, this angle is equal to this angle, and then side of this triangle is equal to this side is equal to this one. Then we say, if by chance if side angle side of one triangle is equal to side angle side of the another triangle, then we say these two triangles are your congruent. Okay, and if these two triangles are congruent, after that you can apply your CPCT rule. That means corresponding parts of the congruency of the triangles, congruent triangles. So this is the first of all, this is the first rule. Side angle side of the one triangle should be equal to side angle of side of the second triangle. Now see, I am going to discuss with the second part. This second part, in this part he said that angle side angle of one triangle is equal to angle side angle of the second triangle. Once again you can say your triangles are congruent. See, this is again you can draw the triangles. In this chapter we have to use the I think we have to use the color pens or sketch pens for our solutions, because that makes the difference, okay, of the angles and sides. So that's why I'm using these different colors. You also have to, students, you also have to use the different colors for the triangles and for the angles, okay. Otherwise sometimes this chapter presents a problem. So angle side, this is your angle, first angle, this is your side, and angle of the one triangle is equal to the angle of one triangle. This is equal to this side and angle. So by chance if angle side angle of one triangle is equal to angle side angle of the another triangle, once again you can say that your triangles are congruent. So these are the some concepts are given. Similarly, see, the third is that is your angle side means angle side means see, this is the third part, okay. So in the third part he said that this is your first triangle and I am going to draw, this is your second triangle, this, okay. And I said that angle side, so that means this is your angle, this is your angle, this is another angle, and this will be your side. So angle side of the one triangle is equal to angle and side. Angle should, all these things should be in continuity, okay. I think everyone know what is the meaning of the continuity, okay. So you can take this angle, then you have to take this angle. You can't say this angle and then another, okay. Yeah, angle side, so you can't say angle and this side, okay. No, that should be in continuity, in some order, okay. So angle side of one triangle is equal to angle side of the another triangle. Then we say these two triangles are once again congruent. The next is a side congruence rule. It's a very easy. I think everyone can understand it. That means what you want to say. This is the first triangle, and suppose this is your side, second triangle. So in that side, all the sides, this is equal to this. Then we say these two triangles are congruent. And last is that is a right angle triangle, okay. So I'm going to rub this one. See, this is your last fifth rule. In the fifth part he said that if there is a one of the your right angle triangle like this is a right angle triangle, and this is your second right angle triangle, okay. So in this case he said that if both the triangles are your right angled, and then hypotenuse of one triangle, this is a hypotenuse. I think everyone know this. This is your hypotenuse. So hypotenuse of one triangle is equal to hypotenuse of the second triangle, and side of the one triangle is equal to the side of the this another triangle. Then we say, once again you can say these two triangles are again congruent. Congruent means with the same size and with the shape. Okay, so such type of triangles are congruent if we follow these 5 rules. So these 5 rules are given in your book. I will give the notes of all these chapters and all these basics in your homework. Don't worry. Okay. So first of all, I want to introduce these. So these are the 5 rules that we are going to solve here. Here the solution in your book for the second part is given. Okay. So now I want to discuss this second part. The second part is that is your angle side angle of this congruency rule. Now what is your angle side angle rule? Okay. So actually there's some in the case number second and third some little problem is there. So that's why I'm going to solve this second rule. This is your second rule. Okay. So in the first part, in the case number 1, it's a very easy. He said that suppose this is your first triangle and suppose this is your second triangle. Then this is your first triangle and suppose this is your second triangle. Let it be your A, B, C, and this is your D, E, F. So suppose if the angle and side and angle of one triangle is equal to angle, side, angle of the another triangle, then you can say that triangles are congruent. It's not necessary that all the sides are equal. So suppose if they all are equal, then in that case you can say your triangle ABC, this is a symbol for the congruency, okay, is a triangle ABC is congruent to triangle your DEF. So this is the first case that is given in your book, okay, solution is given in your book, and this is case number 1. Similarly, in the second case, he said that, now I'm going to discuss case number 2, okay, case number 2. Now, he said that if by chance this type of a triangle is given A, B, C, and second is a smaller one, like this. Once again, I'm going to use a colored chalk. Okay, see, suppose this is your another triangle. This is your A, B, C, and this is your D, E, F. Then, now what is it? See, I'm going to discuss with the, just I want to introduce you. This is your first part and this will be your second. Yeah, angle, side, angle. So it is given on the page number 115. You can see the solution from here, but I'm going to solve, see here. So now I'm taking a case number 2. In this case, he said that if by chance AB is greater than your DE, then how you can show that these two triangles are congruent? See, now if in this case AB is greater than DE, in this case we can take any point P on AB so that PB, this portion PB is equal to your DE. Okay, so we have to take this and this, both are equal in length. After this, once again you can use your first criteria of the congruency, that is your side, angle and side of the one triangle. Side, angle, side of one triangle is equal to side, angle, side of the another triangle. Okay, so in this case you can say in triangle PBC and in triangle DEF PB, okay, is equal to DE, and angle PBC is equal to angle DEF, and then after this side BC is equal to EF. So this is your side, angle, side. So by this rule you can say these two triangles are congruent. So you can say that's a triangle PBC is congruent to another triangle that is called your DEF. Okay, so these two triangles are congruent. Now what was the problem is here? See, if these two triangles are congruent, then you can use your CPCT rule. So by CPCT, their corresponding parts are equal. That means angle B is equal to angle E. Similarly, you can say that your angle PCB is equal to angle DFE. Now this is your problem, because in generally it is given that your angle ACB, okay, so what is the given angle ACB is equal to angle DFE. Okay, so this is a given, but here you have proved that this angle are equal. So this is a contradiction. This is a contradiction to the given. So that means if you have taken, this is a larger, if you have taken AB is greater than DE, that's your wrong. That means AB always equal to DE. Okay, because if we take a larger, then you will say, see here, this angle and this angle are equal, but that is a contradiction to your given part. So this is the second case he has proved in your book, and after this we will discuss about the third case. Now third case is similar to the case second. So just I want to give an introduction of this one. Okay, case number third. Now he said that if this part, suppose this is your triangle, this is the first triangle. Okay, this is your A, B, C, and this is your triangle, another triangle that's equal to D, E, and you can take like this. This is a bigger one. Okay, so this is your D, this is your E, and this is your F. In this case, he said that if your DF is greater than your AC. The same concept is here. So you can take any point here so that this length and this length both should be equal. Once again, you can use a side angle side property, and then you can show that this side and this angle are equal, but that is a contradiction to the given part. So once again, that is equal to this is a problem for this assumption. So that's why AC is always equal to DF. So this is the your proof is given for this your angle side criteria of the congruency. That's all.